Alright, let's work on another LeetCode problem. So today, our first problem of the day is going to be LeetCode number 78, subsets. Given an integer array nums of unique elements, return all possible subsets, the power set. The solution must not contain duplicate subsets. Return the solution in any order. Okay. This seems like a backtracking problem. Off the bat, it feels like backtracking if we're asked to return all possible subsets. The idea is that the problem, I guess, is that how do we know whether or not we've already added a subset? Because there's no real clear condition. There's no real clear condition as to sort of condition to really choose when to stop. So I'm thinking of maybe like a sort of really simple or the maybe straightforward solution would be to use a queue instead. So this is the non-recursive, so this is the iterative method. So use a queue instead. Start with a let me think. So we have the values 1, 2, and 3. We want to create that and into 1, 2, 3. Then with 1, we only want to do 1 and 2, 1 and 3. Then with 2, we want to create 1 and 2 and 3. Then with 1 and 2, we want to create 1, 2, and 3. And that's it. So we kind of want to maintain, I guess, an index as to where the last element was, I guess. I know that in, what was it, tree level order, the solutions I took a look at did something very clever where they used a for loop based on the number of or based on the layer to pop X number of elements from the queue, which I think was a really smart idea. Maybe we can employ something like that here. So basically we just say, okay, so for empty one, we go through all 3 of them. Then we start with the ones. And in this case, we add everything, or we start with an empty and we'll start with 1, right? And it'll say starting from the index at 1 and onwards. And then we'll start with the index at 2 and onwards, then 3 and onwards. But is there a pattern as to how many we go through? So for 1, we get... So this is the first... this is like the sort of first iteration that we want, where we want to go through with an empty array and create 1, 2, and 3 as duplicates. Then we want to create, with these, we want to start at 2. So 1, 2, not 2, 2, but 2, 3. So we want to take this one. We want to take this one and then go for the rest of them. What if we did, so first iteration, create a bunch of elements of size 1. So that'll create 1, 2, and 3. Second iteration, start at the next available. Well, we can check, right? Maybe we can check to see if the element is the last element that we added. No, but then that runs into the problem of we don't check all of the elements. So that won't work either. What if we create a list of sets? And then so if we create a list of sets, then there should be no duplicates. And then we also get the benefit of no duplicates, and then we also get O of 1 dot contains checking within the set, as far as I think. That could be wrong actually for the set. I assume that the hash set is O of 1 contains checking in a similar way that the hash map is. So in that case, maybe we can create a list of sets. Create a list of sets. Then for each set, create a duplicate set, except for the empty set. How do we stop the empty set from being added, or from being reused? That'll be interesting. I'll have to think about that some more. How do we stop that? Then, for each subsequent round, we check if we can add the element into the set. And if so, we add them to a copy. So you start off with an empty set that produces 1, 2, and 3. And this will go from 0 to 3, or 2. Then then the first iteration goes to 1, 2, 2, because that doesn't get duplicated. 3, 2, 3, technically 3, 2, but, and this is from 1 to 2. Then this is 1, 2, 3. The problem is that this becomes 2, 3 as well. This stays because that you just create a copy. You create a copy here. So then you get 1, you get 1, 3, you get 1, 2, you get 1, 3, you get 1, 2, 3, then you get 2, then you get 2, 3, then you get 3, I think it makes sense to add to add the copy into the set, but the question is, how do we stop elements from duplicating? Because the idea is that, okay, we first, so this is like the first pass, then we do 1, 1, 2, 1, 3. So this is the add one pass. Then we do the 1, 1, 2, sorry, 2, 3. This is here. So this is the add one pass. Then we do this creates the add, and then we added those elements, which is not what we quite really wanted. And then we did 2, and then 1, 2 again, and then 3. We did 1, 3 first, then we did 2, 3. The problem is that this and this are duplicates. This is the add 2 pass, right? Because we added this one in the initial one, where we added 1, to the element. Where we added 1 to a copy of solo 2, and that created 1, 2. But we also created 1, 2 when we added 2 to here, which is not really what we wanted. So how do we stop those elements from overlapping with each other? What if we did something different? What if we did, starting from this, and then we did add one pass? Then this is the add 2 pass. Then 3, 1, 3, 2, 3, 1, 2, 3. Honestly, that could work. So we start with an empty, and then we just do those passes. Okay. So we could do, in that case, oh, also, this will probably be an O of 2 to the n runtime. And space, because we're creating a power set. I think. This seems like an expensive operation, and considering the fact that the length is at most 10, then yeah, I assume that it's it's an expensive operation if the number of length in the problem is 10. So let's get coding. So let's create our list of sets. Is a mutable. We'll create a mutable list of mutable set. Actually, this could just be a set of integers. And really, they don't actually even need to be sets. They could be list of integers as well. We'll still call them list of sets though. And then we can say nums dot for each num. And we'll start with an empty set. So empty list of. And then we can say list of sets for each list of sets dot add list plus num. And then return list of sets. So ideally this should add into the list of sets the list itself plus the number. And I think that's actually it. Let's run the code and let's see what how this goes. Empty list of int. Is it just empty list? I know that there's a declaration of it. Yeah, empty list. It doesn't like the fact that we're adding it in. Okay, we'll call this a new list is a mutable list of list int, and new list add, and then new list dot for each new list, we do list of sets add list. We can do some print lining here, but I think this ultimately works. Let's run just an example with 0. Cool, let's run in the submit and see how far we can get. Alright, cool. This was a pretty straightforward one, all things considered. Subsets. I think this is the first subsets problem that I've dealt with using this. It's not quite backtracking because there's no I don't think there's as much sort of recursion here going on. I think it's more of just like creating these subsets. There's not really a I guess like a condition to check against in most cases. Like if we think about the partition equals subset sum, then we're looking for a specific target. If we're doing the number of like the number of elements, all the subsets that equal to a target, then that one also has a sort of constraint where it has to be within the target. Or if we're looking at permutations, then the permutations one has a specific limit where we have, well, the length of the original array, right? But this one doesn't really have those elements of those style of backtracking. I could be wrong though. Maybe this is actually a backtracking problem, but yeah. In any case, so the idea is just that we create a base element, and then we go step by step by adding each element in line. Because they are a subset, it really doesn't matter in which order they're added in, but since naturally we sort of have this tendency, at least in the English-speaking world, to read things from left to right. So we just do left to right, and then for each step we add one, or we add that element. And that guarantees that for each element we don't run into duplicates, because of the fact that we will never have a situation where we will go through and add an element before we won't add an element and then iterate over it again. The time that we iterate over the number is the time when we add it into all the possibilities. But in any case, I hope you learned something, and I'll see you for the next problem.